Hi everyone, welcome to Join Hub. This is Sanjana, and in this video we will be studying about network layer design issues of computer network. Network layer design issues, we have 5 network layer design issues which we will be going through one by one. The first one is store and forward packet switching. Store and forward packet switching. So we have to connect everything with the name itself. So it will be something related. It will be first it will store, then it will forward. Okay, it is something like that. Okay, then here we have the diagram. Okay, now looking into the diagram, we have okay. So here we have P1. This is host one. Okay, this is host H1, and this is host H2. And inside both of these hosts, we have processes. So here we have process P1. See, process P1. This is process P1, and here also we have process P2. Okay, now this H1 is connected. This whole oval shape. This is an ISP's equipment, Internet Service Provider. Okay, and inside that we have routers. All these A, B, C, D, E, F. They're all routers. Okay, and there here we can see a packet. Okay, this is a packet. Okay, now this packet is trans. This packet was sent from host 1 and it have to be received to host 2. Okay, and this is a LAN. So what happens over here is host H1 is directly connected to see over here, it is directly connected to the ISP's equipment. Okay, it is directly connected to the ISP's equipment, and over here, see, when it is reaching H2, it is somewhere outside. Okay, it is inside the LAN. It's in a separate Ethernet, must be of an office or something. Okay, now here we can see here that a host with packet. This host H1 is sending the packet. So a host with a packet to send. So this will transmit it to the nearest router. The nearest router is A in this case. So first it will transmit, the host H1 will transmit the packet to A. Now that can be either in its own LAN or over a point-to-point link in the ISP's equipment. Okay, now this packet is stored here until it has fully arrived. So it is stored here in A until everything have arrived. That is, it will come part by part, right? So until the whole packet is arrived, it will be stored there. Once the whole packet is stored there, it will finish the process by verifying the checksum. The checksum will be verified and it will be moved on. Then once the checksum is verified, it is forwarded to the next router. So here it is going to C. Then along the path, so then it will go to E to F. So here it is LAN. Okay, and then it will reach H2. Okay, until it reaches the destination host where it is delivered. That is store and forward packet switching. We have to remember all these elements. We have a host H1, a host H2. Inside host H1 we have a process P1, and inside host H2 we have a process P2. Then we have an ISP's equipment, and inside the ISP's equipment we have routers A, B, C, D, E, and outside ISP's equipment we have F router in the LAN. Then we have a packet between A and C. See, we have a packet over here. So how does this whole thing work? A host with a packet. This host is having the packet, and the packet have to be transmitted. So it will send it to the nearest router, now either in its own LAN or over a point-to-point link to the ISP. Then the packet is stored here until it has fully arrived and the link has finished its process by verifying the checksum. The checksum have to be verified. Then it is forwarded to the next router along the path until it reaches the destination host where it is delivered. This is store and forward packet switching. This is store and forward packet switching. Okay. Next one, we have service provided to the transport layer. What are the services provided to the transport layer? We have 3 services that we should be learning. First one, the services should be independent of router technology. Whatever service, this is about network layer. Like, so whatever services is there, it should not be dependent on the router technology. That is the first one. The services should be independent of router technology. Then the transport layer should be shielded from the number, type, and topology of routers present. So see, after network layer comes transport layer. So this transport layer should not be connected or not be dependent of this number, type, and topology of the routers. It should not be in. It should not be dependent on the routers. So the transport layer should be shielded from the number, type, and topology of the routers present. The network addresses made available to the transport layer should be use a uniform numbering plan. Okay, here it should use a uniform numbering plan. Why? And even across the LAN or WAN. Okay, here the network addresses made available to the transport layer should use a uniform numbering plan even across LANs and WAN. So these are the three services provided to the transport layer. That is the network that provides services to the transport layer. The services should be independent of router technology. Then the transport layer should be shielded from the number, type, and topology of the routers present, and the network addresses made available to the transport layer should use a uniform numbering plan even across LANs and WAN. Please forgive the mistake made over here. Okay, and then the third one, implementation of connectionless services. So if connectionless service is offered, the packets will be injected into the network individually. The connection is not there. I will give the diagram. See, here there is no connection. In this case, we are taking for a connectionless service. There will the packets will be injected individually. So at that case, the router will be depending on each other. And here in connectionless service, we don't need any setup. So no advanced setup is there. And the packets, we call them as datagram. We call packets as datagram. Packets are called in what? In connectionless service, the packets are called as datagram and the network is called as datagram network. This is in analogy with telegrams. Okay. So that is connectionless service. Now here we have this figure. Look over here. So here I'm having host H1. So these are the same things that we have learned before. Okay, these are the same things which we have learned in store and forward packet switching. What all things they have? We have H1, host H1, host H2, and instead host H1 I have process P1. Here also have process P2. And I have all the 6 routers. I have A, B, C, D, E, and F. But here look at the packets. I'm having 4 packets. Before I only had 1 packet. So here when all the packets want to go, there will be congestion. You know what congestion is? There will be traffic. Okay. So to avoid the traffic, so this is connectionless service. So it is to each router, the packet is injected independently. So in case if we have taken anyway, it have to come here. The packets have to go through A in any case. Why? Because that is the only router which is being connected to host H1. So it have to pass through it. But after that, it have two options. Either the packet can choose this path or this path. That is A to B or A to C. Okay. Now say the packet 1 have chosen to come to through the path A to C. Again, it is having options. C, it is here. The packet is over here. Say the packet 1 is over here. Then it have two options. It can go from C to D or C to E. Okay, C to D or C to E. So if the packet 1 chose this E position, and then it have to go like this. So that is one way how the packet can go. Okay, I'll remove all this to avoid confusion. Okay, now again, so that is one example of how it can happen. So like that, there are multiple routes. Okay, Now here I have four tables: A stable initially, A stable later, AC stable, and E stable. So we have to check. Okay, I hope it is legible. Okay, now look over here. A stable initially. So while writing the table, we have to make sure that over here we write the destination. Here we write the destination. Here we will be writing the destination, and here through which path it will be going. So this is the format how which we have to write it. So now we can check. Okay, A stable. So how is it reaching A? Look over here. A stable. A is over here, right? Okay. Now this is the destination. We have the destination A, B, C, D, E, and F. So what we will do? We will write all the destinations down. Okay, how will we write? We can write like this. We have A, B, C, D, E, F. So I have written all the destinations. Now through which line? See over here, destinations I have written. Now here what do I have to do? I need the line. So which line, through which line it can reach the destination. So it is starting from H1. So it's starting from H1, and it does not have any other router to go. It is coming directly to A. See, A is our destination. A is our destination, and it does not have any other route to come to A. So what will I do? There is no other way. So that is nil. Okay. Now I am going to see for B. If I want to reach B, what way can I choose? So which line? So that is B only. Okay. See, I can reach B through B only. Okay, there is no other way. So I will write here B. Next one you have to find for C. C, which way can I come? There is no other way. Only C is the option. Okay. So C I have written. Now I am coming to D. So if I want to reach D, I have two options. I can come either through B or through C. Okay. So it is your choice. You can write B or you can write C. So here in this case I am writing B. Now I am checking for E. Where is E? E. Again, E I have two options. I can come through C or I can come through D. Okay, that is my choice. So here in this case I'm writing as C. I'm coming through C. That's what I'm writing. Okay, C. Then I have F. F means it is starting from A, right? Because this is A stable, so it's starting from A. We take in consideration of A stable. So that's why we are taking A. So here A is anyway the starting point, right? So I need to reach F. So A through after A, where is it going? Is it going to B or is it going to C? So I am taking C in this case. It depends. Okay. So here after C we don't have to write E. We can just write C. So I've written here. I'll be writing C. Now again coming to this is first A stable initially. Now there will be congestion and things, right? Okay. So at that time, how will I write? Again here the destination is same. A, B, C, D, E, F. Also the A1, A part, the line is nil because there is no other option. Fine. Then we can go and search for B. Okay, I'll make it a little bit small. Okay, look over here for B. Now B, I can reach B through B only. See, A to B is B only. So I can write over here B. C. There is no other way. Only through C I can come. So C. D. D. I can come through B or C. Okay. I'm choosing B. Okay. Now E. E. I can come through C or B. So in this case, I have in A table initially, I have already come through C. So this path is now in a traffic. So what will I do? I will choose another path. So instead of coming like this, I will come like this, like this. So I will take B in this case. So that is B. So F will also have to be B. That is A stable initially and A stable later. Just like that, you have to do for C stable and E stable. So again, for C stable and E stable also, C stable and E stable also, this destination will remain same. Okay, that is I'm having A, B, C, D, E, F, and A, B, C, D, E, F. So here it is C stable. So we are looking at in relation with C. So the packet is starting from C. Okay. So C to A. It is going like this. C to A. Okay. We are looking in contra. Okay. C to A it is going. So there is no other option. It is just A, right? So A over here. Now we are looking from C stable to B. So C stable, there is no direct connection between C and B. Right, there is no direct connection between C and B. So it can go either through D or through A. So now I am choosing C can reach B through A. So I will be writing here A. Now C, it is nil. Then C wants to reach D. C wants to reach D means it can either go directly to D or through E. So here in the textbook it is given as E. So it is we can also write it directly. So you can go directly to D. So it can be D. Or if we want, we can go through E also. Then E. E is stable. C to E. That directly to E. Then F to E. So that is about C stable. Now coming to E stable, if we are taking E stable. Now where is the packet is starting from E. Okay, the packet is starting from E. So it's starting from here. So A means I have two options. I need to reach A. So I can go like this, C to A, or I can go like this, D to C to A, or I can go D to B to A. There are so many options. I can choose any way I want. So what will I choose? It is up to you. So in this case, I am choosing C. It is over here. So I'll go like C to A. That is through C I am going. Now I want to reach D. Here also I can either go like this or like this. So that is C A B or E D B, like that. So now I'm taking through D. So B D. Now C means it wants to reach C. So C only. D means A to D. So D. And this is E stable. So nil. And F directly to F. So this is about connectionless service. We have to choose different paths based on the condition. This is how you write the table for implementation of connectionless service. Now, implementation of connection oriented service means here it is based on the connection. It have an advanced setup. Okay. and this connection is called as a virtual circuit. Okay. Virtual circuit, and the network is called as virtual circuit network. It has physical circuits, and there will be a path through which the data packets will be sent. There will be physical path. So that is implementation of connection oriented service. So here, when a connection is established, a route from the source machine to the destination machine is chosen. We will choose a route, and the connection is set up, and it will be stored in the tables, and the route is used for all the traffic flowing over the connection, just like a telephone system, how it works. And then when the connection is released, it will be terminated. The virtual circuit will be terminated. So in connection oriented service, each packet carries an identifier telling which virtual circuit it belongs to. So it have an identifier in this virtual circuit network. So this is a router. This figure is a routing within a virtual circuit network. Okay, so here you can see we have an extra host. So we have H1, host H1, then we have host H2, and here we have host H3. And inside each of the hosts we have process P1, P2, and P3. And the router is just the same, A, B, C, D, E, and F. And then we have packets. So we have packet 1, 2, 3, 4. Okay, inside the ISP's equipment. So how is it working over here? How do we do that? Okay, we have A stable. The A stable, it is coming from H1. Okay, I'll make it a little big. Okay, it is coming from H1, right? Okay, so H1. Also, there is a connection from H3 also. A is being connected to H1 as well as H3. So I'll write both of those, H1 and H3. Now I will have to give them an identifier. Since they both are coming to A, I will give the identifier as 1. Okay. Now that is A stable. And then this is from where it is coming. And A is giving it to C. A is passing it to C. So C. So when it reaches C, the first one, H1, the identifier will be 1 itself. But when H3's packet reaches to C, the identifier has to be changed, because it cannot be similar one. Because if we give both the packets as identifiers 1, then the data will be, the routers will be confused of which host have sent it. So when it reaches over here, the second one I'll give it as 2. The identifier will be 2. Okay. Now I'm looking C stable. C stable means from where is it coming? It is coming from A and it is going to E. So I have A. Both the packets are coming from A only. And the first one's identifier is 1, second one's identifier is 2. Then see, it is going to E. So E I will write over here. Again, the identifiers name are 1 and 2. Okay, now I am taking E. It is coming from C and it is going to F. So C, and then identifiers will be 1 and 2, and it is reaching its destination as F. So F, F, 1, 2. So here I can write this is the in part and this is the out part. Okay. This is about connection oriented service. Now we have comparison of virtual circuit and datagram network. This is our last design issue. Okay, now what is the issue? So we have lots of issues. Okay, now issue datagram network and virtual circuit network. It is going like that. The first issue is a circuit setup. Circuit setup. Okay, circuit setup. Circuit setup is not needed for datagram network. It is connectionless, right? So it does not need. But for virtual circuit network, it is required. Connection circuit is required. Then we have addressing. next issue is addressing. Bear me with the handwriting, please. And each packet contains the full source and destination address. So in datagram network, each packet will contain all its source and destination address. Okay, this thing is the packet. Okay, I don't because I don't have time to write the packet. Okay, so that is a packet. Then we have source and destination address. So each packet will contain the full source and destination address in datagram network. But in virtual circuit network, the packet will only contain a VC number, which virtual circuit number. The packet will only contain that. Now the third issue is state information. State information. So state information is that the routers, it is about routers are, okay. The routers will not hold any state information about connection. So the routers will not have any state information about the connection. But in virtual circuit network, the VC requires router table space per connection. It does need the state information. Then coming to routing. Okay, each packet is routed independently. See, datagram network, it does not have a prior connection or something, so it is done independently depending on that particular situation. Whatever it is done, so it is done independently. And virtual circuit network, how is it? The route is chosen, so right when the virtual circuit is set up, the route will be chosen and all the packets will follow it. Okay, it will be followed. Follow the setup, right? Similar to the circuit setup. Okay. Now, effect of router failures. Okay, effect of router. In case a router fails, what will happen? Here, there will be no particular effect in datagram network. Like some packets might be lost. Packets will be lost because of the crash. Packets will be lost because of the crash. But in virtual circuit network, every virtual circuit that is being passed will fail. If the router is failed, then it will be terminated. In datagram, it will only lose some packets, but in virtual circuit, it will be terminated. Then the quality of service. We have quality of service. So quality of service is difficult in datagram network, but it is easy if enough resources can be allocated in advance for each virtual circuit. So this is difficult. This is easy if it is utilized in the proper way. Also the condition control. Condition control is difficult in datagram network. Is difficult, whereas it is easy in virtual circuit if there are enough resources allocated inside. So these are the 1, 2, 3, 4, 5, 6, 7. Yeah, 7 issues or the comparison between datagram network and virtual circuit networks. So this is about network layer design issues. So what all did we learn so far? We have learned about store and forward packet switching. Then here there we told about, so in that we don't have any table or anything, we just familiarized with it. So how does the packet go and things like that. Then the service provided to the transport layer, we learned about 3 services provided. Then implementation of connectionless service, we learned how the tables are array stable initially, later, then C stable, E stable, and all those things. And then we learned about connection oriented service. Okay, how we implement that. And then we learned about the comparison of virtual circuit and datagram network. So this is all about design layer issues. Hope you've all understood it. Thank you.